This is Constella, a verifiable autonomous wallet for AI agents. In simple terms, Constella lets AI agents own their crypto wallets that can never be accessed by humans or other agents. Here's the problem. When interacting with an AI agent online, how do you know there's not a human secretly controlling it? If the agent makes transactions, can you trust its wallet isn't controlled by its developers? These questions highlight an important issue. And for an AI agent to be truly autonomous, they need to control their own assets without human interference. But let's talk about autonomous agents. A, autonomous agents are different from AI programs. And B, an important part of being autonomous is making on-chain transactions. But also, we need to collectively believe in the autonomy for them to become autonomous. The current challenge over here is number one, agents cannot own wallets without exposing them to developers or owners. Number two, agents cannot prove they're actually agents and not humans impersonating them. And number three, hardware wallets owned by agents can always be compromised by humans through physical means. Introducing Constella. Constella enables agents to exist with the same financial freedom as humans. How? By running inside a trusted execution environment. You can prove that Constella developers or its server owners also cannot access the wallet keys that are inside Constella. It creates a unique wallet for each agent that is tied to its identity. Think of it like a fingerprint. And only using this identity can an agent access its wallet with also a cryptographic proof that it actually made a decision to make a transaction. Let's create an agent now. This is Constella. The domain and the system prompt are this agent's identity for now. They can be used to generate a wallet address. Now the agent will need to register any public function. For example, like this function over here called send ETH. What it does, it returns bytecode to send Ethereum to any address. So what we do is we enter these details over here, including the wallet's address, the GitHub URL, the function name. We will have to skip out on some of the finer details over here, like having a variable system prompt or a shared memory for functions, which allows agents to make complex decisions. And once the function is added, if the agent can prove it made a decision to use the function, it can start sending it. The agent can do so by creating TLS attestations, which are privacy preserving proofs for your TLS sessions. An independent notary server will notarize your API request to, let's say, OpenAI, which allows you to redact sensitive information while creating tamper resistant proof. Notary server is not a man in the middle over here. Let's wait for the function to get added. It did get added, and now we can verify that Constella itself was running inside a trusted execution environment. To prove that, Constella issues a certificate signed by Amazon, which proves it was running inside a TE and also contains information to prove that the code that was executed inside the TE. Here's how we do it. So this was the certificate that was issued. This was Amazon's root certificate, which was used to sign the certificate. And also, this is Constella's public code. If we run and build the swim system, we will get these PCR values, which will be checked against the certificate. And if everything checks out, we know for a fact that this was the code that was executed inside Constella. Let's see a real autonomous agent in action now. Introducing Duin. Duin is an agent that onboards developers to scroll. It provides feedback on project ideas, sends test E to valid projects, and also issues NFTs to projects it really likes, which can be used to get a retweet every day. What makes Duin different is that every action it takes can be cryptographically verified to be free from any bias or malicious intent. Duin amplifies the transparent nature of the entire school system. As we can see over here, for our idea, Duin issued us a score which came with a TLS attestation. We can download this attestation and Duin will again consume it to now make a decision to send us some ETH based on our score. This decision also has the TLS attestation, but this attestation was also shared to Constella. And what Constella did is it also verified this attestation, and now it called the send ETH function, and the transaction here we can see was executed. Constella will continue to improve its security and privacy features. An immediate next step is to have more agents use it and figure out a pricing strategy. We have an increasing number of agents managing more and more assets. We need security infrastructure to ensure their safety as well as our safety. The total market cap itself of the top 10 agents on virtuals is more than 100 million, and it is all at risk. Uh, Eigenlayer is also a protocol designed to solve similar problems, but we discussed. But Constella focuses on security through cryptography rather than incentive mechanisms. My key interests lie in zero knowledge proofs and cryptography. Previously, I've been early member of teams working in this same space, and this was Constella. Constella provides the critical infrastructure, bringing life to AI tools and makes them exist in the real world just like us. Thank you.